All right, hello. We are going over section 5.3. Actually, this is day 3. Sorry, I have the wrong number there. But the goal is the same. We're going to solve equations with exponents greater than 2. So like mostly x cubes, right? Or there'll be some x to the fourth in this video too. And we're going to do it with factoring. So there's all these different factoring cases. And since this is kind of our last day on 5.3, full day on it, I'm going to mix in all the different factoring cases. So this is kind of a guide of all the different ones. We have like a square thing minus a square thing. And then there's a cube one minus a cube, or a cube plus a cube actually. There's two different ones there. We'll talk about a grouping one in this video where there's 4 terms to it. And then there'll be this pattern that goes x to the fourth, x squared, and a constant. And it'll look kind of like this one. We'll cover that in this video too, actually. And then just our regular old straight trinomial case where it starts with x squared. We just kind of factor it like normal. As always look for a GCF. Always pull to the front first. I should say probably to say always pull the GCF to the GCF to the front first if possible. So look for that first all the time on a factor question. Okay, so before we get too far into the new lesson, pause the video and in your notebook, right? You should have your notebook out while you're doing these. Try a couple review questions about what does it mean to factor, and then factor the two below. Pause the video. Okay, factor means to break apart, right? And so it's sort of the reverse of multiplying. So I always explain factoring with just regular numbers. So if I was to factor the number 10, that just means break apart 10 to 2 times 5, right? And that's all factor means, is break it apart into things that multiply to the original number. So with a polynomial, on this first example, we have a GCF of 2 and x. So I'm going to bring that to the front, and I'm left with x and minus 3. Divide by 2 and pull out an x. The second one, there's no GCF, but this is the square minus square case. And so what we have to remember here is if we make it into two little binomials, to make a 4x squared, we need a 2x and a 2x. And then to make a 49, essentially it's a square root. So we need a minus 7 and a plus 7. That multiplies to negative 49. So that's a square minus square factoring where we break it apart into these two things. Okay, and so that's really what gets hard, in this lesson today. There's all these different factoring ones, right? So in those warm-ups, we did a GCF factor, and then we had this square minus square case, right? And they're going to mix all these together, and so it gets tricky to figure out what to do in each situation. All right, so a general big picture of this solving with exponent of 3 or more, right? So it's kind of a big picture is, back when we had x to the first linear, we just solved it with algebra steps, like add 6 to both sides to get rid of the minus 6, divide by 2. All right, and then we did quadratics. This was chapter 4, and there was 4 different ways for solving a quadratic. All right, but one of which was to factor it apart to linear things. So like this quadratic actually factors to x minus 3 and x minus 4. Multiply up to positive 12 and add to negative 7. So what we actually did is we made that into 2 linear problems, right? At this point, if we set the two things to 0, x minus 3 equals 0, x minus 4 equals 0, that's actually 2 linear problems, right? And so we can solve them with our algebra steps to get 3 and 4. Okay, and so with an exponent of 3 or more, we just want to break it down into either x squared or x to the first, right? Because we already know how to solve x to the first with our algebra steps, and we already know how to solve x squared with all these different methods. So, in a previous lesson, we did like an x cubed minus 64, and that's the cube minus cube case. We talked about how it factors to this, which is now a linear part. And then we have a quadratic part, an x squared, that we can solve with our methods back in the x squared world, right? So that's the idea, is to break it down into lower exponents and then solve the parts using the methods that we learned previously in algebra. Okay, so What's going to come up for this first factoring, what we're going to need is actually, it's a different version of what I call like long factor. So basically, when we have a trinomial, these are both 3 parts, trinomials. The one on the left, because it has x squared, we talked about you can just put x and x here, and then multiply to 30 and add to 11. Okay, so boom, done your factored. Well, if there's no GCF here for the one on the right, so we can't pull the 2 out, then we can't do our x and x trick because we have a 2x squared. Okay, so when we factor this, we have to do what I call long factor, which starts by doing 2 times 5, and then find a pair that adds up to 7. So in this case, it's 2 and 5. So in this method, we split up that 7x into like 2x plus 5x. Right, we use the numbers from over here. And then we bring down the other part, so 2x squared and plus 5. Okay, and then sometimes this is also called factor by grouping, because now that we have 4 terms, you group the front 2 and group the back 2. And a GCF out of the front 2 is 2 and x. Leaves us with x plus 1. And out of the back 2 here, we can pull out a 5. Leaves us with x plus 1. Okay, and then our 2 factors are the parts that match, which are x plus 1, and then the parts that are in front. So that would be, in this case, 2x plus 5. Okay, and that's our 2 little factors. Handwriting got a little out of control, so there it is, a little bit nicer. All right, so the reason I bring this up is we are going to do factoring next that has 4 terms to it. And so it's actually going to be a lot like this process we did over here where we're going to group them and do GCFs. Okay, so the case we're dealing with today, or this first one here, is it has 4 terms. Okay, and we're actually going to factor it and then solve for all the real and imaginary. So see if what I just babbled made any sense. See if you can write this one down and actually factor it apart and get the answers. So I'd pause the video and give it a shot here. Okay, so with 4 terms, you're just going to group the front 2 and group the back 2. So it's just like this method here, except we don't have to do the split step. So in some ways, it's actually easier because we already have 4 terms to start. Okay, so it's kind of hard to see there now because I covered it up a little bit. But out of the front, we'll actually be able to pull out x squared. And that will leave us with a single x here and plus 2. Right? They both have at least x squared in them. So we pull that out. Then in the back, they're both negative, so I'm going to pull out negative 3. Leaves us with x plus 2. All right, and now just take the parts in front. That makes 1 factor. So x squared plus, no, minus 3. And then the parts that match, right, when we do this correctly, these parts will match. And that makes our other factor x plus 2. Okay, and this one is solved, so we have to actually keep going and solve it. So now that I've broken it apart to a linear thing and an x squared thing, I'm just going to set them to 0 and then solve. So the one on the left, going to add 3 to both sides and then take the square root to cancel out the square. This is just more algebra steps. And just don't forget here you have 2 answers, right? So it would be both plus and minus the square root of 3. And those are real answers because it's a positive number underneath the radical. So it's plus or minus square root 3. And you could write it as a decimal if you really want, but I'm just going to leave it that way. And then the other one just minus 2 from both sides. Okay, and so here's our 3 answers. There's 2 irrational ones here and then just 1 regular rational number for the other one. So 3 total answers. Okay, so next case is special case number 4, and I don't really know what the heck to call this thing, but basically the way you'll recognize it is it'll have 3 terms, and it'll go x to the 4th, x squared, and constant. Okay, and so what this 3-term factor is really, really similar to the problem I have in blue here. Okay, so the problem in blue, what we basically did was we just broke it apart into 2 little factors and said, okay, to make x squared, we need x and x. And then the other two things have to multiply to -4 and add up to -3. Okay, so in this particular case, I believe -4 and +1 will multiply to -4 and add up to -3. Okay, and then basically we solved it, blah, 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 blah. We got x equals 4 and x equals -1. Okay, so when we factor the situation on the left, it's going to be very, very similar, right? And so I'm just going to set up my two little factors here and see, hey, can you figure out, instead of having x and x here like we did before, any guesses what we're going to have here and here now that this is x to the 4th? So if you said, Mr. Westphal, it's going to be x squared and x squared, then you would be right. Right? So x squared times x squared will give us x to the 4th. Okay, and then the rest of it is exactly the same as over here. We just have to multiply to -4 and add up to -3. So -4 and +1. All right, and we can see that this works because this is really the same thing broken apart, right? Like the x squareds make the x to the 4th, and then -4 times +1 makes the -4. And then if we were foiling, in the middle we'd have -4x squared and +1x squared, right? And that would add up to the -3 in the middle. Okay, so I'm just showing that to show that this factored form is really the same thing as what we started with. Anyways, little out of control, right? So now that we factored it apart, you can actually factor this one on the left further. This is the square minus square case, but essentially we don't need to, right? If I just set them equal to 0 right now, we can just use algebra steps and solve both of these. So instead of factoring some more, I'm just going to set them to 0. This particular one, we're going to add 4, then take the square root. And so just don't forget two answers here. Plus or minus 2 is the square root of 4. And then the one on the right, -1. Ooh, this is exciting now, right? Now we do the square root. And because it's a negative number, we're going to get an imaginary answer. And actually, square root of -1 is I. So our answer here is plus or minus I, right? So it's two more imaginary answers. Okay, so this case, the trick is to watch for having having an x to the 4th x squared and then a constant. That's when you'll know to do this particular pattern. All right, so what I'm going to do for the rest of the time here is I'm just going to throw different situations at you. And here's all our different factoring situations. And you kind of got to figure out which one of these it is, right? And then try and factor it from there. So here's your first one. Pause the video and give it a shot. All right, so first thing is we should get 0 on one side, right? So if the equation doesn't have that, let's do that quick. Add 12 to both sides. Then hopefully we recognize that this has 4 terms. So when that happens, we're going to group. So we're going to group the front two, group the back two. Look for a GCF out of the front two would be x squared. So I'm going to pull that out. And then out of the back two, we can pull out a 6. Okay, and things are looking good because these parts match. So our two factors are the parts that match, x plus 2, and then the parts that are in front, so that would be x squared plus 6. Okay, and now just set the parts to 0. So x squared plus 6 equals 0, x plus 2 equals 0, and then solve these. So this one, minus 6 from both sides, and then take the square root. And we would get x equals plus or minus, and this is going to be I because it's a negative square root, and then root 6. So there's no real way to simplify root 6. So we're just going to leave it as an I for the negative part and then a root 6. All right, and then the other one's a little more straightforward, just minus 2, and we get x equals -2. So we got 3 answers, 2 imaginary down here, and then -2 for this one.